हेलो बच्चों, वेलकम टू वी गाइड टीवी. Our chapter name Solutions, and this is part 9. In this video I will explain the concept of solubility and solubility of solid in liquid. Here solid is the solute and liquid is the solvent. We will see some example. I will take water as my solvent and sodium chloride as my solute. Sodium chloride, we will add sodium chloride into this water and we will stir this. We can see that sodium chloride got completely dissolved into this water. Now we will see another example. I'll take water as my solvent and oil as my solute. I will add this oil into this water. We can see that oil did not get dissolved into this water. From this, we can come to some conclusion that some solute like sodium chloride got dissolved into water, but at the same time some other solutes like oil did not get dissolved in water. It's because of two reasons. We will see that two reasons. The first reason, polar solute dissolves in polar solvents and non-polar solute dissolves in non-polar solvents. We'll see the first one, polar solute. Polar solutes are generally it is inorganic compounds. Example for polar solute is sodium chloride. Why it is polar? Because sodium chloride will dissociate into Na plus ion and Cl minus ions. And examples for polar solvents is water. Why water is polar solvent? Because water dissociate into H plus ions and OH minus ion. So these two, sodium chloride and water, formed charges, so that we can call the sodium chloride and water is polar. So this water is polar solvents. Now polar solute dissolves in polar solvents. Right. Next, non-polar solute dissolves in non-polar solvent. Example for non-polar solute. Generally, organic compounds are non-polar solute. Example, naphthalene, anthracene, etc. And example for non-polar solvent is benzene. Now we will see example for the first one. That means polar solute dissolves in polar solvents, and next we will see non-polar solute dissolves in non-polar solvents. Now we are going to see polar solute dissolves in polar solvents. Example, I'll take a polar solvent, water. To this, I will add polar solute sodium chloride. Will it get dissolved? Yes, because solute and solvent are polar, So definitely this sodium chloride will get completely dissolved into water. But if you add, now I'll give you another example. I'll take water as my solvent and I will add into this. So I have taken water as my solvent, and also water is a polar solvent. To this I will add solute. The solute taken here is non-polar solute. So I will add one of the non-polar solute, naphthalene. So here I have taken naphthalene as my non-polar solute. I will add this non-polar solute naphthalene into polar solvent water. Will it get dissolved? No, it will not get dissolved, because non-polar solute will dissolve only in non-polar solvents. And even you can add, you can take another example, anthracene. Anthracene is a non-polar solute. If you add this non-polar solute anthracene into polar solvent water, it will not get dissolved, because non-polar solute dissolves in non-polar solvents. Now we will go for the second point. Non-polar solute dissolves in non-polar solvents. We will see example. So I will take a non-polar solvent, that is benzene. What is the molecular formula of benzene? C6H6. Benzene is a non-polar solvent. To this I will add non-polar solute. Non-polar solute, so I want to add naphthalene. Non-polar solute into non-polar solvent benzene. Will it get dissolved? Yes, it will get dissolved, because non-polar solute dissolves in non-polar solvent. If you add another, we can say another example. Anthracene is a non-polar solute. So anthracene, if we add into non-polar solvent benzene, will it get dissolved? Yes, it will get dissolved, because non-polar solute dissolves in non-polar solvents. But I'll take water as my solvent. Water as my solvent, and water is a polar solvent. I will add a non-polar solute into this. Will it dissolve? No, it will not dissolve, because non-polar solute will not dissolve in it will not dissolve in polar solvent. We know non-polar solute will dissolve only in non-polar solvent. Similarly, we will take another example. I'll take non-polar solvent benzene. To this I will add polar solute. So I want to add polar solute sodium chloride into non-polar solvent benzene. Will it be dissolved? No, because we know polar solute will get dissolved only into polar solvents. Hope you understood this solubility concept. And now we will go for the next topic. Saturated solution and unsaturated solution. So I'll explain the saturated solution with one example. So I'll take here a solvent. Here my solvent is water. And this water can dissolve. That means, see, I have taken this much quantity of water, right? I have taken this much quantity of water, and this much quantity of water can dissolve only this much quantity of sodium chloride. If I add more sodium chloride into this, it will not get dissolved, right? So I will add this much quantity of sodium chloride into this water and you stir this. This sodium chloride will get dissolved into this water, because this much water can dissolve only this much quantity of sodium chloride, right? Now you know this is a sodium chloride solution. Now I have already added sodium chloride into this water. Now this solution is called sodium chloride solution. To this sodium chloride solution, I will try to add some more sodium chloride. Will it get dissolved? No. If you add this sodium chloride will remain as same as crystal at the bottom of the beaker. Right? This solution is called saturated solution. Now we will see the definition of saturated solution. A solution, that means saturated solution, is a solution in which no more solute can be dissolved at the same temperature and pressure is called a saturated solution. Next one is unsaturated solution. So I will explain this unsaturated solution with one example. I will take this much water. Now this is water, right? So to explain this unsaturated solution, I will take water as my solvent. Why I am taking always water as my solvent? Because water is the universally accepted solvent. So to explain this unsaturated solution, I will take water as my solvent and I will add little less quantity. First I want to, I have taken water as my solvent, and you know this water can dissolve this much quantity of sodium chloride. If I add more than this water cannot dissolve more quantity of sodium chloride. That means this much water can dissolve only this much quantity of sodium chloride. So from this sodium chloride, I will take some part of this sodium chloride and I will add into this water. Then I will stir this. Yes, sodium chloride will get dissolved into this water. Remember, again some more sodium chloride is left out here. If you add this left out sodium chloride into this water, it will get dissolved. So at the beginning I told this much water can dissolve this much quantity of sodium chloride. So that first we have added, so we have this much quantity of sodium chloride. From this you take little sodium chloride and you add into this. That sodium chloride will get dissolved into this water so that you will get sodium chloride solution. And this much quantity of water even can dissolve the left out quantity of sodium chloride. Right? So this type of solution is called unsaturated solution. So here we will see the definition of unsaturated solution. Unsaturated solution is one in which more solute can be dissolved at the same temperature. Hope you understood this, and we will go for the next topic, that is called dissolution and crystallization. We will see what is dissolution. Dissolution means when a solid solute is added to the solvent, some solute dissolves and its concentration increases in solution. This process is known as dissolution. So we will take again water as my solvent. I have taken water as my solvent, and you know this much water can dissolve this much quantity of sodium chloride. So I'll take some part of sodium chloride from this and I will add into this water, and I will stir this. You know, sodium chloride will get dissolved into this water. Again, I have some more sodium chloride. Again, I will add so that means the left out sodium chloride, I will again add into this what? This sodium chloride solution. That sodium chloride also will get dissolved into this water. That means concentration increases. Right? This type of solution is called, and this process is called dissolution. So what is dissolution? When a solid solute is added to the solvent. When a solid solute is added to the solvent, some solute dissolves and its concentration increases in solution. This process is known as dissolution. Now, as we added this sodium chloride into this water, now I can call this as sodium chloride solution. Now, this solution is called sodium chloride solution. That means our solid sodium chloride is dissolved into this water. Now, once the sodium chloride solute dissolved into this water, then we cannot see this sodium chloride crystals over here. That means we know in this water or else in this sodium chloride solution, sodium chloride solute is present. There are many sodium chloride solute is present here, but it is not visible. Now, this solution is called sodium chloride solution. If we wait for some time, here we know here sodium chloride solutes are present, but it is invisible. That means it is not visible. So this sodium chloride solute will collide each other. As it is colliding each other, some of the solute particles will get separated out from these solutions. So I repeat, here solute particles are present. It is invisible. That means the solute particles are not visible. These solute particles will collide each other. Because of this collision, some of the solute particles, that means the particles which is colliding, these collided particles will separated out. That means because of, see here I repeat, here the solute particle is colliding. Because of this collision, some of the solute particles will get separated out from these solutions. That means we can see that solute particles over here. Right, here we have found some sodium chloride crystals. This solute particles means what? This is sodium chloride solute particles. That means sodium chloride crystals. So here we have seen the formation of sodium chloride crystals. And this process is called crystallization. What is our next topic? Crystallization. What is crystallization? Once the sodium chloride solution is formed, some of the solute particles in this sodium chloride solution collide with the solid solute particles and get separated out of solution. This process is known as crystallization. Right? So I repeat, we have prepared here sodium chloride solution. So some of the solute particles in solution collide with the solid solute particles. That means sodium chloride solute. That means sodium chloride solute particles are colliding with sodium chloride particles and get separated out of solution, and this process is known as crystallization. Now, once the crystals are formed, once the sodium chloride crystals are formed, you will wait for some time. you can see that again this sodium chloride crystals will get dissolved into this solution. That means now you can see the sodium chloride solute crystals. If you wait for some time, you can see that this solid sodium chloride solute crystals will get dissolved into this solution. That means these crystals will disappear. When these two crystals are disappeared, again another two crystals will be formed. That is also due to collision between sodium chloride solutes. So here two processes happening. How many processes happening here? Two processes happening. What is the first process? First, crystals are forming. So what is the first process? The formation of the crystals. What is the second step? The crystals formed will be disappeared. That means the crystal formed will again get dissolved into this solution so that it will disappear. So that this will disappear and another two sodium chloride crystals will be formed. So here how many processes happening? Two processes happening. If you wait again for some more time, that means when a stage is reached, these two processes occur at the same rate. That means rate means speed. So when a stage is reached, these two processes occur at the same speed. Under such conditions, number of solute particles going into the solutions will be equal to the solute particles separating out. I repeat, when a stage is reached, these two processes occur at the same rate, and under such conditions, number of solute particles going into the solution will be equal to the solute particles separating out. And this stage is called equilibrium state. And this stage is called equilibrium state. In this equilibrium state, what is happening? Solute at the beginning, we will add solute with the solvent. You will get solution. Solute you will add at the beginning, you will add solute with the solvent. So you will get solution. If you wait for some time, what happens? From this solution, what is get separated? Solute gets separated from this solvent. So this arrow mark is saying about the forward reaction. That means first reaction, solute plus solvent gives solution. And this reverse arrow mark says from the solution, the solute got separated. So solute and solvent got separated. So we can, and these arrow marks are called equilibrium reaction, and you know here reversible reaction is taking place. That means this is a reverse arrow, and this arrow mark is called the forward reaction, and this arrow mark is called backward reaction. And as in this reaction we have forward reaction as well as backward reaction, so we can call this entire process as a reversible reaction. Hope you understood dissolution and crystallization. Now we will see the definition of crystallization. Some solute particles in solution collide with the solid solute particles and get separated out of solution, and this process is known as crystallization. Next we will see the last topic, that is solubility of solid in liquid. It is in terms of temperature effect. So the effect of temperature on the solubility of solid in liquid. Like this case, it follows Lee chart layers principle. That means if the dissolution process is endothermic. What is dissolution process? I have already explained what is dissolution process. That means solute will get dissolved in solvent, so you will get a solution, right? And this is called dissolution. So if the dissolution process is endothermic, that means dissolution process is endothermic means we need heat for the reaction. So we need heat for the reaction to happen. So in this case, so if the dissolution process is endothermic, that means delta H of the solution is greater than 0. So if delta H of the solution is greater than 0, that means when the temperature increases, solubility increases. When the temperature decreases, solubility decreases. And if the dissolution process is exothermic, that means in the dissolution process, heat is emitted. You know, endothermic means heat is taken. That means for the reaction, heat is taken. And if the dissolution process is exothermic, that means in the dissolution process, if the heat is liberated, then delta H of the solution is less than 0. That means when the temperature increases, solubility decreases. And the temperature decreases, solubility increases. That means solubility is inversely proportional to temperature. Next, effect of pressure. Pressure does not have any significant effect on solubility of solids in liquids, because solids and liquids are very less compressible and practically remain unaffected by changes in pressure. So what is the effect of pressure? Pressure does not have any significant effect on solubility of solids in liquids. The reason is solids and liquids are very less compressible. Hope you understood the total concepts. If you like this video, please press like button, and you can subscribe this channel, and you press the bell button so that you will get the notification whenever we upload videos, and you can share this video with your friends. Thanks for watching V Guide TV.